Hey, what's up, Logic fans? It's Ash again. Today we're going to cover section 1.6 of the text. This is our fourth section on propositional symbolization, and we're going to learn how to properly symbolize the material biconditional and some interesting features of it. All right, let's rock. Okay, so very quickly, let's take stock of where we're at. All right, so we've introduced, our fundamental concern is inference. That's what logic is all about. What follows from what and why. And in order to come up with a mathematically rigorous, philosophically satisfying account of inference, we have to introduce some symbolic machinery, and we've kind of been going through and introducing that machinery. So, for example, we've introduced propositional variables, lowercase p, q, r, and s, with or without subscripts. Okay, in section 1.7 and 1.8, we will soon be calling these forms, as you'll see. We've introduced propositional constants, the capital A, the capital B, the capital C, with or without subscripts. We have as many of them as we need. Okay, then we can symbolize negation with the tilde symbol. We can symbolize conjunctions with the ampersand symbol. We can symbolize or with the wedge symbol, and we can symbolize conditionals, the arrow symbol. Okay, so we've got all this symbolic devices sort of floating around. There's one more symbolic device we have yet to introduce, and that is the subject of this video, which is the tribar or biconditional. Okay, so it's just three little bars here. Sometimes you see text use two arrows, like an arrow pointing in both directions. What I use here is the tribar symbol, and this is read if and only if. Okay, so let's jump into understanding this fifth and final symbolic device we're going to need for future work. Okay, so this is the General Biconditional. Okay, and we're going to talk a little bit more about forms and generality in 1.7 and 1.8, but the basic idea is that biconditionals have this general structure. Okay, there's a left part, a tribar, and a right part, just like if this were ampersand or arrow or wedge. So they look basically the exact same way, except you got these three little bars here. This is read P if and only if Q. Okay. And so just like with a conjunction or a disjunction, there's a left part and a right part. We're going to do something a little bit different with biconditionals, but if you do need to refer to the left side or the right side, sometimes we'll just talk about the left-hand side of the biconditional, or the left side of the tribar and the right side of the tribar. So there is that nomenclature. But let me just give you a couple of examples in ordinary English of biconditionals. Okay, so here are some examples in ordinary English of biconditionals, and in these examples we're disregarding whether the claims are actually true or false. Doesn't matter whether true or false, it's still a biconditional. Notice they all have this if and only if aspect to them. Okay, all of them have it because that's the defining feature of a biconditional. So this statement here says it is raining if and only if it is wet. So the left side of the biconditional is it is raining, and the right side is it is wet in this case. This is indeed a false biconditional, but that's how you would symbolize it. Just like if you had a false disjunction, you would symbolize it the same way, okay? Johnny will go to the movie if and only if I go to the movie. It's hard to tell whether that's true or false because we don't know anything about you or Johnny and what arrangements you may have made with one another, but this is nonetheless an example of a biconditional, and notice it has the if and only if. There is fire if and only if there is oxygen. This is a nice example. This is a biconditional with the if and only if, and the left side there is fire, the right side there is oxygen, but it is indeed false. You can have oxygen without fire. I'll be getting into that shortly. All primes are odd if and only if 2 is not prime. That's a really interesting one and complex, better left for later time, but it is an if and only if statement, and therefore it's a biconditional. Okay, that's what a biconditional is, and it says all primes are odd. Notice that statement taken by itself is false. Okay, all primes are odd if and only if 2 is not prime. 2 is prime. Okay. Anyways, 2 plus 2 is 4 if and only if grass is purple. Okay, so you're getting the idea. These are all examples of biconditionals. But what I want to get into is a little bit about what this if and only if statement actually means and amounts to. Okay, so biconditionals, as the name suggests, right, bi as in two. Okay, biconditionals really are just two conditionals. So technically, we don't even need this symbol. Okay. That's because what a biconditional is sort of shorthand for is the assertion of two conditionals. So we could get away with just if P then Q and if Q then P. So given that we've got if then and given that we've got ampersand for and, we really don't need it. But this is sort of a succinct way of saying if P then Q and if Q then P. All right. So we talk about the left to right direction of a biconditional. So the left to right direction is the thing on the left side, arrow the thing on the right side. So in this case, generally if P, then Q. We're going to do some examples in a second. And we also have the right to left direction, if Q, then P, which is the right to left direction. Okay. And notice this all is just embedded in the language, if and only if. So I've got the and emphasized here. And I want you to take it seriously. So, P if and only if Q says two things. It says first, P if Q and P only if Q. Okay, so P if Q is just if Q then P, right? And P only if Q is if it's the case that P, then it's the case that Q, right? So it really is just an assertion of two conditionals. Now, notice in the last video when we were discussing the material conditional, okay, what we saw was that a conditional can be true and its converse. So if P then Q can be true and its converse if Q then P can be false. In the case of a biconditional, what's being asserted is that both directions are in fact true, and we noted that that can happen. So this is a succinct way of saying, yeah, in the particular case of this P and this Q, if P then Q and if Q then P are in fact both true. That's the sort of meaning of the statement. So let's do a couple of examples to make sure we're clear on this. Okay, so for this example, I've got two if and only if statements, two biconditionals arranged for you. All right, so what I want you to do for both of these biconditionals, so for example for this one, is I want you to find the left to right direction of this one. I also want you to find the left to right direction of this one, but also find the right to left direction. So find the left to right and the right to left direction of each. Finally, I want you to tell me whether you think the statement is true or false after you've found the left to right and right to left direction. And it's going to be true just in case both the conditionals are true. Otherwise, it's false. So both of them have to be true in order for the biconditional to be true. Okay? And that's the sort of meaning of a biconditional. All right? So pause now and give that a shot. Okay, hopefully you've had a chance to work this one out for yourself. If you didn't get it, that's all right. We're going to work it out together, all right? This is your introduction to biconditionals. So our first example was there is fire if and only if there is oxygen, okay? The left to right direction of this biconditional is if there is fire, then there's oxygen. If this thing, then this thing. The right to left direction is if this thing, then that thing. So if there is oxygen, then there is fire. This is a false biconditional. This biconditional is false, and hopefully you can intuitively see that, because in order for it to be true, both the left to right direction and the right to left direction have to be true. And in fact, one of them is true, but one of them is false. Can you figure out which one? Hopefully you're able to figure out that B is indeed false. Okay, B is supposed to be the false one. So the idea is that, hopefully you're sitting in a room right now and there's no fire but plenty of oxygen. Okay, so that would be an example of a false biconditional, but it is a biconditional and it has a left to right direction and a right to left direction that we can identify, and it's asserting something, that's false. Okay. Let's go ahead and look at our second example. 2 plus 3 is 5 if and only if 5 minus 3 is 2. This is going to have a left to right direction as well because it's a biconditional. So if 2 plus 3 is 5, then 5 minus 3 is 2. Similarly, the right to left direction is if this, then this, right? So if 5 minus 3 is 2, then 2 plus 3 is 5. And both of these are true, and therefore this is a true biconditional. Okay, let me give you one more example so you can see what some things look like if we introduce symbols. Okay, so moving to some examples with symbols in them, can you go ahead and find the left to right direction of this biconditional, and can you find the left and right directions of this biconditional? Pause now and try that. And do feel free to present your answer symbolically. Okay, so don't use English writing if, so use the arrow. Okay, pause now. Okay, so symbolically, the left to right direction of A if and only if B is if A, then B, right? A arrow B. And the right to left direction is B arrow A. Okay, so it's two conditionals. Okay, it's a biconditional. Now, this one's a little bit more complex because the P part here, the left side, is more complex, and the Q part here is more complex than it was compared to this one. But it's still the left to right direction, the left side, which is this whole thing, arrow, the right side. Okay, and so that's what it looks like. Similarly, the right to left direction is the right side, this side, arrow, the left side. All right, taken as a whole, and that's how you do it, and there's nothing more to it. Now notice I didn't ask you to evaluate whether these claims were true or false, because we don't know what A and B are standing for, or C, D, and E, so you don't have a way to evaluate that. But that's the assertion of this is that both of these conditionals are true. The assertion of this is that both of these conditionals are true. Okay. Okay, now, there's something really fun we can do with biconditionals, and it has to do with this notion of material equivalence, which I'm going to explain in the next video on 1.6, so 1.6b. But in order to introduce that, we first have to get clear on the concept of a corresponding biconditional of a pair of sentences. So the best way to do this, I think, is by example. Now, this might sound very complex, but trust me, it's actually really, really easy, and you can do some pretty nifty stuff with it. Let's suppose that your professor picks a pair of sentences out of a hat. First, he picks this sentence out of a hat, and then full replacement, so he could pick A again, but he doesn't. He picks this one. All right, so your professor picks two sentences out of a hat, and you now have a pair of sentences. The corresponding biconditional of this pair of sentences, of these two sentences, is the first sentence, tribar the second sentence. In other words, A tribar C. So the corresponding biconditional of this pair of sentences is A if and only if C. Okay, so all you're doing is you're taking the first sentence, you're putting it down, putting a tribar down, and now you've got a new sentence. This new sentence is the corresponding biconditional of these two sentences. I'm going to tell you what we're going to use that for in a minute, but first let's just make sure you've got this down. So let's do an example really quick. Okay, so here's a pair of sentences for this example that I just pulled out of a hat. Also, here's a pair of sentences that I just pulled out of a hat. For this pair of sentences, find its corresponding biconditional. For this pair of sentences, find its corresponding biconditional. Pause now and try that. Okay, hopefully you've had a chance to do that, but, for this pair of sentences, the corresponding biconditional is this sentence, tribar, right? This sentence, J. Similarly, for this pair of sentences, it's going to be this sentence, okay, tribar, this sentence. So ultimately, it's going to look like this. And this is the corresponding biconditional of this pair of sentences, okay? Now, so all you're doing is taking the first sentence, tribar the second sentence every time. That's all that you need to know for this. That's what the corresponding biconditional is. In the next video, we're going to use this notion to define something really cool called material equivalence. So we'll see you on that.